S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, you might be aware of the courses like machine language, artificial intelligence. You might have seen the course curriculum also. So today in this video, we are going to do a very important chapter which is a backbone of this machine language, artificial intelligence, statistics, stats. In stats, we will study different kind of calculation. Like we will calculate the mean, we will calculate the variance, standard deviation, we will calculate the distribution, binomial distribution, we will calculate a geometrical distribution, we will calculate a Poisson's distribution. So we will study in this that how we will make the calculations in this, and when you will do the further course, then you will analyze that how this particular calculation is important, because the same calculation you are going to do or convert into softwares like R programming, like in Python. So this video is very important as far as if you are doing any further course with the AI or machine language and all.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
Hello students and welcome to the S. Chan Academy. My name is Kanhaiya Jha. So basic of stats. So basic of stats is like this, that we have a data. How to make the calculations with the data? Because we have a random data with us. So how to manipulate the data, how to arrange the data, and how to make a calculations with the particular data. Okay, so let's take an example to understand in a better way that how to make the calculation. Let's take an example that in a class there are 20 students. In a class there are 20 students. Now what happens is everyone has scored a particular score. Suppose I take example of 5 students. The roll number 1 has scored 96%. The roll number 2 has scored 46%. Roll number 3 has scored 20%. And roll number 4 has scored 36%. Like take the example like this. Now what happens here, that roll number 1 is getting 96%, roll number 2 is 46%, roll number 3 is 20%, roll number 4 is 36%. Now in this particular data, suppose we calculate a mean. The mean is very simple, that we add all the data and divide it by the number of terms. So in this case that will be 4. But how can we analyze? Suppose the mean comes to be this one, x. But how we can understand that which contribution is highest? Because an average will give us one particular figure which all the student has scored. So for that we calculate the relative mean. In the relative mean, when we will calculate, then we will get that roll number 1 has the highest contribution. So basically what I mean to say is that in this particular stats, in this particular chapter, we will learn the different calculation which will make us understand what exactly data is, how we break the particular data, and after breaking the particular data, how we make the particular calculation. As we can see here, these are the the basic definition of that: collection, presentation, analysis, and the reasonable interpretation of the particular data. So how we collect the data, how we present the particular data from one particular form to another particular form, how we are analyzing the particular data, that how the particular variations in the data can be calculated, and then we make the particular calculation. So this is the first thing. Now this is the particular method that we generally do. The first one is called as descriptive, and second one is called as the, what if you can see that inversional method. So first of all, we'll take a multivibrate, bivibrate, or univibrate particular data. We shape the data, then we make the correlation. What is the correlation between the particular data? And then we make the particular calculation. In this, if you can see, we'll make the group and we'll proceed with the particular test. Okay, so first of all, if you say data, we make the data here. Suppose the data is, again I take the student, that A, B, C, D, E, let's take E, E and F. So these are the students, the name is A, B, C, D, E and F. First of all, that again we take a score. The score is 96%, 40%, 30%, 85%, then 30% and then 20%. Okay, so let's discuss in detail how we arrange the data. This data is given to us. So first of all, we will calculate the mean, which is denoted by x bar. Mean can be calculated as total number, that is 96 plus 40 plus 30 plus 85 plus 30 plus 20 and divided by the number of terms. So the number of terms are 1, 2, 3, 4, 5 and 6. So these are 6. So when we get this particular result, suppose that we are getting this result as x dash. Now what we will do is that it will give a relational data when we say that 96 minus of x dash, this gives the contribution of A. Similarly, you can calculate relational data with B, with C, with the D, with E and F. So what we conclude here is that we will get the exact the score given by the particular students. Or we can do one more thing in this. We can break it in terms of frequency. In terms of frequency, in the sense that suppose that we have 4 categories. The first category is A, the students who are scoring 60 to 80%, B 80 to 95 plus, C who are in the average of 40 to 60. So we can say that 0 to, suppose 10 students are in one category, 10 to 20 students are in a second category, 20 to 30 and so on. So what we do is that we generally make a group of the student and we make a particular category where they exist. So we say that 0 to 10 students score this one, 10 to 20 and 20 to 30. If you look at this, if you look at this particular data, you can see shaping a data. Shaping a data is very important, where we shape a particular data after making a particular shape or making a particular relation between the data, then we can make the particular calculation. So in this case, we have a data with us. We arrange the data in a proper form. After arranging the data in a proper form, we will apply the formula, and applying the formula will make the calculation. In this, we have a test. First, we will check the confidence level of the particular value, that what is the confidence level of the particular value. After calculating the confidence level, then we have a t-test. T-test, we will calculate it for one sample. T-test, we will calculate for two sample, or t-test will calculate it for the multiple samples or the paired samples. So then we have numeric set of data. Numeric set of data, what is the center and the shape? The numeric set of data is that making a center in the sense that we'll make a particular variable from where we make the calculation. Let's take a very small example that when we go to the bank, what is the one thing that the bank generally know is account number. If we give our account number, then all the data can be opened. If we give our date of birth, address, name, we cannot open it. So center in the sense that we have to make a particular variable from where we have to access the particular data. Either you are doing in the banking or you are in school and college also, we have to make an enrollment number. Everywhere we have to a particular key thing. A particular key thing is a center. From that particular center, we can make the calculation. From that particular center, we can make the variation in the particular data and formulate the data and then make the calculation with the data. Then we have a definition with a nominal, ordinal, interval and the ratio. As you know that nominal, so we have a basically arranging a data in a numerical value. Either we arrange in ascending or descending, we arrange in a particular value. Then we have ordinal. Ordinal is that depending upon the particular numbers, depending upon the particular rank, depending upon the particular position, we make this particular data. Interval, as we have discussed, that we categorize the data. We categorize the data from one particular type to another type. So when we categorize the data, then in particular category, there are the data which are saying which have the interval, and the ratio is basically that when we are changing one form of data to the another, like we are changing temperature in Kelvin, then addition, subtraction, multiplication, we are changing in the equation form that it is given in the xy form, and we are requiring in the form of x only, we are requiring in the form of y only, right? So this is called as the ratio. Then we have distribution. Is a very important thing in distribution, which is unimodal, bimodal, and symmetric. Unimodal, as the name says, unimodal, you can move from one input to the output, we cannot reverse it. So we can say that it is a linear also, because having a single peak, in the sense that we can proceed from one particular value of data and then we can go to the last value of data. We cannot change the particular data in between. Then the bimodal have two peaks, we can move from both the ways, from A to B and then move from B to A. Symmetric, that has a particular, as we say, the left and right half are mirror images. So then right now we have discussed that what is the data, how we will break the data, how we will analyze the data to make a proper calculation, and how the calculation is generally important. Because unless and until we will centralize the data, then only we can make the calculation. So now we'll take a small break, and after the break we'll discuss what is a frequency distribution.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Hi students, welcome back to our video. So before the break we have discussed the data, how the data is important, how the categorization of the data is important, and how we categorize the particular data and then we make the particular calculations and all. So now we'll study the calculations that we can do. The first calculation that we can do is frequency distribution. Frequency distribution, in the sense that we will, in this what we have is a particular group in which we can say that what is the number of variable it is. Okay, so particular group, and what is the number of variable in this. So group, suppose that this distribution of age, the age is 1 year, 2 year, 3 year, 4 year, 5 year and 6 years. So we can say that here that the frequency is, in the 1 year there are 5 students, in 2 year there are 3, in 7 years, in 3 years there are 7, and the 4 year there are 5, in 5 year there are 4, and in 6 year there are 2 students. So you can see that here that depending upon the age, there are 5 students who are in 1 year, 3 in a year and 2 year. So in spite of writing the entire data, that name, age, what we do is that we make a category. Category depends upon the frequency. Frequency is that how oftenly it happens. So what happens here, in the 1 year there are 5 students, 2 year there are 3 students. So now look at here that what are the total number of students, 5 plus 3, 7, 5 plus 4, total number of students, their category in a very small data. Very small data. Second thing is a group data. In a group data, what we generally conclude is that we will make an interval. The first one is a lower interval and this is the upper interval. So the age group 1 to 2, there are 8 students. In the age group 3 to 4, there are 12 students. In the age group 5 to 6, there are 6 students. So what we need to understand here, that total number of students. 5 plus 3 is 8, plus 7, 15, 20, 24, 26. 26 students can be categorized in a very small table according to their age. That 1 year, 2 year, 3 year, 4 year, 5 year, 6 year. So according to their age, they are categorized here. After that, we can make it more small, that we make an interval. So when we make an interval, then we can see that between the age group of 1 to 2, between the age group of 3 to 4, between the age group of 5 to 6. This is called as the grouped frequency. So in the group frequency, we can see that we categorize a particular group and then we make the particular calculation. So then we have a calculation of the commutative frequency. In the commutative frequency, then we can see that age is given 1, 2, 3, 4, 5, 6, frequency is given, and then we can calculate the commutative frequency as the first group is 5. Okay, so the first one will be 5. Second one will be the addition of 5 plus 3, 8. Then third one will be the addition of 8 plus 7, 15. Then the next one will be 15 plus 5, 20. Then it will be 20 plus 4, 24. And then 24 plus 2, 26. So here we can form in the particular group data also that between 1 to 2 years, the frequency is 8 and the commutative frequency is 8. 3 to 4 years, the frequency is 12 and the commutative frequency is 20. And 5 to 6, the frequency is 6 and the commutative frequency is 26. So here we learn that how we particular categorize the data, as we have seen in the previous slide, that making a center data, making a one variable and then making the calculation. So how it plays an important role that in a class of 28 students, 30 students, okay, we make a small table. In that small table, we put all the data. And from that small table, we put all the data, then we make the particular age group in terms of the group frequency, and then we are making the calculation. So there are, the data which can be split in terms of non-interval, and when they are in interval, we can have the lower interval and the upper interval. And then we can calculate the frequency and the commutative frequency. So this is how we can make the calculation of the frequency and the commutative frequency. Now let's learn. In a class, there are 60 students, right? So in all these 60 students, what is a unique thing is a roll number. No two roll number will match with each other, right? So we analyze them in terms of the roll number. We can say that roll number 1 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and then 50 to 60. So we can say that the entire class is broken into 6 particular group. First 1 to 20, second 10 to 20, then 20 to 30, 30 to 40, 40 to 50, 50 to 60. And then we break in terms of marks. Suppose that we have a first 10 students get an average mark of 60%, second 10 students get average marks of 40%, then 90%, then 80%, then 70%, and then 30%. So what we do is that we make a category of the student. So looking at a data at once, we can say that this group is an intelligent group. This group needs to work hard. So looking at a data. So in this video, I'm focusing to the study of a data where we can break the data. We can make a center key. Center key is a variable like the roll number of the student, bank account number. So from that particular thing, we can make the calculation. We can group the data. And then make the calculation. So all this calculation will enable us to calculate what is the average, what is the mean, okay, what is the frequency. After calculating the frequency, then what is the grouped frequency. It will also gives analysis that which group is better than other. So this is also called as that a comparison of data, that how we compare the data from one particular form to the another form. So concluding in this video, we have learned the data, how to break the data, how to calculate the center of the data, and then how to calculate the frequency, how to calculate the commutative frequency. We will learn more in the coming videos. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.